An array is a group of contiguous memory locations that store elements of the same data type. So an array can only store elements of one type. So if the array is defined to store strings, it can only store strings. If it's defined to store integers, it can only store integers. All right. Now, each array is given a name. So each array has a name, a size, and a data type. In C++, we have what is called zero index array, which means that the first location of the array in C++ is at index 0. The second location is at index 1, and so forth. So if I were to enter the value 5 into this array, here we're saying that 5 is at location 0, right? So 5 is at index 0. That means 5 in this case would be the first element that we have stored in this array. Again, if we were to enter another value, let's say 11 in this array, as you can see, based on location, 11 is at location 6, right? 11 is at index 6. Now, even though 11 is at index 6, if we count, we would realize that 11 would be the 7th element in the array because it's a zero index array. So let's count. 1, 2, 3, 4, 5, 6, 7. So 11 is the 7th element in the array, even though it's at index 6, because the first index is at 0. All right, so that's something to bear in mind. That C++ is a zero index, use zero index. All right. So C++ maintains zero index array. So the first element in the array in C++ is always at index 0. All right. It's slightly different from what you are maybe used to in a language like Pascal that has one as its first index. Okay. All right. So just some things that we need to bear in mind when we talk about arrays in C++. We're saying that each array has a name. There's a unique name for the array. Each array has a size, and each array also has a data type, right? So if we're going to create an array, if we're going to declare an array, these 3 items must be known when we are declaring the array. All right, the next thing about the array is that the size is fixed. The arrays are fixed in size. So if we declare an array to store 10 elements, while the program is being run, we can change it from 10 to something else, right? An array can only store values of one type. So whichever type we declare the array to store the values of, that's the type it will maintain throughout the lifetime of the program. The name of the array is a pointer to the first element of the array. So the name of the array is a pointer to the first element of the array. If you recall from our previous video, we said that a pointer is a special variable capable of storing the memory address of another variable. So we're saying here that the actual name of the array, stores the memory address of the first element in the array. And we will see that when we head over to the compiler to do our implementation. All right, so we're going to look at how we declare an array in C++. So let's declare an array to store the age of 10 students. All right. So to declare an array, we need to know the name of the array, we need to know the data type, and we need to know the size. So in this case, we're declaring an array called age, and it's going to be of size 10 because we're storing 10th age in that array. So we start with the data type, which is int, the name, age, and we specify the size in the bracket here, which is going to be 10 in our case. So this is how we declare an array. All right. We can create arrays of different types. So again, let's create an array with some costs, probably a type double. So you could see Now, before I start the implementation, so we need to establish how many costs we intend to store. So let's say I want to store 5 different costs. So you could say double cost size 5, right? So this declares an array of size 5, and in this array we can store 5 different double values, right? Now we can also declare and initialize an array at the same time. So we can declare the array and we can give it starting values. All right. So let's look at an example of that. So let's say we want to create an array with some grades, maybe of type float. Again, we could say float and give the array a name, in this case grade, and we put on our index. So we're going to specify how many grades we plan to store. Let's say we're storing 5 grades. So here we are saying that we can initialize the array. We can give it the array starting values and we declare the array. So I could put in some grades inside here, but we have to put them in the curly bracket. So like 20.3, 74.5, 80, 94. That's 1, 2, 3, 4. One more. 60.4. All right. So these are 5 grades that we have initialized the array with. So we have given this array some starting values. All right. Now we could also use just about any type to create an array. So let's say we want to create an array to store some, maybe the days of the week or something like that. So if we're going to store the days of the week, we'll be using like string. So you could say string, let's call it days of size, there are 7 days, 7. And I'm going to initialize it as well. So first day is Sunday, Monday, Tuesday, Friday, Saturday. All right, so these are days that we are working with. Okay. So depending on what you're storing in the array, you may initialize it different ways. All right. So here we declare 2 arrays that are initialized, and up here we have 2 that are not initialized. All right. So if we wish to assign values to the array, so I'm going to assign to age, the age array. So assigning. So apart from initializing the array, we can assign values to the array after it has been declared. All right, so let's say we want to assign our age as probably the first value in the age array. So let's say age. So if we want to assign our age as the first one, then let's say we are probably 20. So if my age was 20, I would say age 0 is equal to 20. And that would basically put 20 at the first index of this age array. All right, so let's assume that this is the representation of the age array. So if we say age 0 is equal to 20, it simply means that we are putting 20 right here. All right. And if we want to put another age. Let's say we want to put a friend's age as the second index. Let's say that person's age is 18. It will say age as a second index. Second index is at 1. Let's say age 1 is equal to 18. Right? And for example, you want to put your grandfather's age as the fourth index. You could just say age. Right, so let me just put in the 18 on the presentation so we can actually have a graphic. So what is going on? So we put 18 here, the 18 will appear as the second index here. So the second index is index 1. So if you want to put grandpa's age as the fourth index, let's say age 4, the fourth index. Let's say grandpa is 87. All right, so this would put 87 at the fourth index. All right, good. So that's how we assign values to the array. So we specify the name of the array and the index to which we want to assign the value to, followed by equal and the value to be assigned. All right, so now that we have assigned some values to the array, you might be interested in see the content of the array. So if I want to see the content of the array, we can just print out the values that are in the array. So for example, if I want to see the first age in the age array, I could say cout age. Now, if we just say cout age, we're not gonna get the content of the array in C++. What we're gonna get is a pointer to the first element, because as we would have discussed earlier on, we said that the name of the array is a pointer to the first element, but we'll see that later on. So I want to print out the first item in the array, we'll basically say age 0. And that will give us the first element. So the first element in this age array is 20, as you can see. All right, if I want to see the fourth element in the array, I'll just say cout age 4. And that will print out the fourth element in the age array. Fourth element in the age array is 87, as we can see on screen. Yes, we might be thinking, why couldn't we just write cout age? Let's see what's going to happen if we say cout age. If we say cout age, that's the name of the array. As you can see, we're not seeing the elements in the array being printed. What we're seeing here is a memory address. And this memory is a memory address. And this memory address is the address of the first element. The very first element in the array, that's the memory address of it. And if you recall, when we're doing pointers, we say that if we have a pointer and we want to see the elements that the pointer is pointing, we are to dereference the pointer. So if we dereference this pointer, if I dereference this age pointer, I'm going to be seeing the first element in the age array, which is, where is it? The first element is going to be 20. So if we run this, we will see the 20 coming. There we go. So the name of the array is a pointer to the very first element in the array. So right now we see two different ways that we can access the elements in the array. So we could access the first element in the array by stating the name of the array on the index. That's index 0. So there it is, we get 20. And we're saying too that we can access the first element in the array by stating the array name. If we state the array name alone, we're gonna get the memory address of the first element. And so to see that element, we have to dereference it, because the name of the array is a pointer to the first element. So if we dereference this, we will see the first element in the array. It's 20. All right. Now, if we wish to see the second element in the array, Who can tell me what to do? Yes, you're right. If you said that we can use index 1, then that is it. So we put in 1 as index, and we should be seeing 18 coming up when we run the code. So there it is. All right. So we can just specify the index of the element that we wish to access, and we will have access to it. All right. Now, let's see if we could use the name of the array to access the second element. Now, we say that the name of the array is pointing to the very first element in the array. But remember, in an array, the elements are stored beside each other in memory. So they're neighbors. They're each other's next door neighbor. So what happened is that the fact that the name is pointing to the first element, we could shift the pointer to the next element in memory by simply adding 1, and that could give us a pointer for the next element. That's the element beside the first element. And of course, that would give us the second element. All right. So another way that we could access the second element, apart from just specifying index 1, we could put the name. So the name of the array by itself is the hexadecimal number, which represents the memory address of the first element. So what we're saying is that the second element now is 1 plus that hexadecimal number of the first element in the array. So if we add 1 to this, that is going to give us the memory address of the next element in the array. All right. So if we run this, we're going to see a hexadecimal number coming up. And this hexadecimal number represents the second element in the array. All right, let me take off the +1 so we can make a little note of what the memory address for age is. So for age, let's see. So for age, we have 6FFD70. And we are saying that the next element in the array is located beside this one. So if we're going to add 1 to this, so the next element in the array is right beside it. So it's 6FFD74. All right, as you can see. All right. And of course, if you add 2, you'll get the next the third element. If you add 2. All right. So there it is. Good. So if we wish to see the second element, we go back to 1. But what we're gonna do now is we're gonna dereference this entire number. So remember, we would have dereference age to get the first element. And the dereference age itself, you would have seen the first element of the age array, which is 20. So if we want to see the second element, all we need to do is to dereference age +1. Age +1 is the address of the second element. So when we dereference that address of the second element, we are going to be seeing the second element, which is 18 in this case. All right, so there we have it. So that's how another way that we can access the elements in the array. So again, if you want to access the third element, just put age 2, age +2, all right, and dereference that. Okay, there is, did we put in, oh, we didn't put in anything in H2, so the value that is there is not really something meaningful, right? So right now I'm seeing a random value there, which is not meaningful. So I won't bother to put it on the screen. But we would have assigned a value to index 4. So if you want to see the value at index 4, who can tell me which number to add to age? So we add 1 to age, and we get the second element. We add 2, we get our third. So what do we add to get the element at index 4? I think your guess is 4. So if we do that, 4 + 2 = 8. 4 + 2 = 8. 4 + 2 = 8. 4 + 2 = 8. 4 + 2 = 8. 4 + 2 = 8. 4 + 2 = 8. 4 + 2 = 8. 4 + 2 = 8. 4 + 2 = 8. 4 + 2 = 8. 4 + 2 = 8. 4 + 2 = 8. 4 + 2 = 8. 4 + 2 = 8. 4 + 2 = 8. 4 + 2 = 8. 4 + 2 = 8. 4 + 2 = 8. 4 + 2 = 8. 4 + 2 = 8. 4 + 2 = 8. 4 + 2 = 8. 4 + 2 = 8. 4 + 2 = 8. 4 + 2 = 8. 4 + 2 = 8. 4 + 2 = 8. 4 + 2 = 8. we'll see our 87. All right, so we can access the elements that way. Another way that we could access the element is simple putting age 4. All right, and that too will give us the element and the 4th index of the array. All right, so that's how we access the elements. All right, so armed with this bit of information, let's say we want to print out the entire content of the array. So let's say we want to print out printing the entire content of the age array. Let me not use the age array because some of them are not assigned. Let's use the days array. All right, so I'm gonna print out all of these in the days array. All right, so what we can do, the long way, we could write 7 different statements to do the printing. So we could say cout the days 0. We could use this method, or if we want to use the pointer method, it's up to you. Perfectly fine anyway. All right, so that will print out the first day. We print the second day. We could print day 1, print the third day, day 2, day 3, and that day 7 is index 6. So of course, this would print out, all the days of the week, all right? So you can just break the line here. Just put in an end line. End L. That will break the line for us. Now, even though this will work, this is not the best way to implement this. I'm sure based on what you would have done in class before, you can come up with a more creative way, more intuitive way of doing the very same thing. So there we have the days of the week being printed on the screen. So as you can see, we have a number of repeated lines. If you observe here from line 19 through to 25, everything is pretty much the same apart from the index. So it's only index that is different. So if we can think of a way that to reduce the code from say 7 lines to probably 2 or 3 lines, then that would be quite intuitive, quite provide you a more efficient implementation, right? And yes, there's a way. So instead of going this long route, which I will not delete from the screen, I'll just comment it out. So we look at a shorter way, and I want you to think of that shorter way. What's that shorter way that we could have done this? All right. And I know your answer is a loop, the for loop. Let's see how we could use the for loop for this. So we're gonna say for, we are looping 7 times. So we're gonna go from int I equal to 0. So basically the index is what is gonna be changing. So we're moving from 0 to 6. We're saying I less than or equal to 6. And we're increasing I by 1 each time. All right. So pretty much what we want to happen is several repetitions. We need a variable to be changing from 0 to 6. And then what we can do now is just to grab any one of these lines, just one of these lines, and pop in here. And we need to change one thing. What's that? Yes, we're going to change this 1 to I, because I is going to be changing from 0 all the way up to 6. And that's it. So instead of writing 7 different lines, we can print out the entire content of the array using 2 lines. And this applies to all arrays. Once you're printing out the entire content, this will work for it. It doesn't matter the amount of elements. If it's 100 elements, there's no need to have 100 different lines. The two lines will print out the entire content of the array. And there we go. Just like that, we printed out the entire content of the array. Right? It doesn't get harder than that if we wish to print out the contents of the array. All right, hope we're following that. In a similar manner, if we wish to print out the content of the grade array, the same concept could be applied. So I'm just gonna do a copy and paste here. I want for you to pause the video and try to write the codes to print out the content of the grades array. Just look at the number of elements that are in the grades array. We have 5 elements in there. So you're going to use a for loop, preferably, to print out the content of the grade array. All right, so now that you have implemented it, so we are going from 0. So since it's size 5, it means that the first element is at index 0, then 1, then 2, then 3, then 4. So we're going to be looping from 0 to 4, not to 5. It's from 0 to 4. And we are printing the content of the grade array. And that's it. So this will print out the content of the grade array. So there we go. All right, so that's how we print content of the array. All right, the last thing that I will do in this video, let's see how we could calculate the sum and average of the grades in the grade array. So we'll look at how we can compute the sum and average. All right, so we're gonna work out the total and the average of the grades in the grades array. All right, now if we're gonna work out the sum, we need a variable to store the sum. So since the grades are of type float, we're gonna declare a variable of type float called sum, initialize it to 0, and that will be used to keep track of the total. We also need one for average, so we'll call one sum avg. All right, so let's jump straight into it. Again, to find the sum of the grades, you just need to traverse through the array. And in this case, we're using the array, the loop. I'm gonna do it manually. I'm gonna use 5 different lines. And then we can look at, not necessarily 5 different lines, but I'm gonna access them manually. And let's can look at how we can achieve the same thing using a loop. So if we wanted to do it manually, we would say something like sum is equal to the grade is grade 0 plus grade 1. And while doing this, just think about it. What if it was 100 different grades? You'd have to type for this 100 different times, right? You'd have to be typing so many different times. You'd have to be entering grade. So grade 3 plus grade 4, right? So we're adding up the value at index 0, index 1, index 2, index 3, and index 4. So all of those values will be added to get the sum of the grades. Nothing's wrong with that. So we print that out, see out. The sum is going to be sum. I'm going to print out the average too. The average is AVG. Let's work out the average though before we actually print it. So the average is going to be equal to or the sum divided by the number of grades, in this case it's 5. So nothing is wrong with this method, just that it's not the most efficient. So there it is. So the sum is 329.2 and the average is 65.8. A more intuitive way of doing it would be through the use of the loop. So instead of writing, consider having 100, 200 different grades in the area, you're going to have to write sum is equal to, you're going to have to write grades like 100 different times and so on. That is not very smart. That's not the best way to do it. So a better way to do it, we could use our for loop. So we could say for int count equal to 0, count less than or equal to 4, count increment. And what we're going to be doing here is that we are going to be doing the addition here. So we're going to be saying sum is equal to, so because we're in a loop, we're going to have to say sum is equal to sum plus grade count at 0. So as we loop, as we iterate, count will change. So it will change from, so it will start off with sum at 0, so it's going to be 0 plus grade count. Count is going to start out at 0, so it's going to go from 0 all the way up to 4. All right, and at the end of the day, all the grades will be added, as you can see. All right, so if we run this, there it is. So you get about the same answer, but using far less, may not be far less lines if you're counting the lines, but in terms of the time that it will take to actually implement, it's less. All right, so that's it. So we'll continue on array in our next session. So go through the videos, rewatch the videos, practice, and all the best.